Okay, to start this proof, we look to what we want to try to prove. We are trying to prove that triangle LPM, this triangle over here on the left, is congruent to triangle LPO. Well, in order to do that, we don't have a whole lot of information about that triangle yet, but I do have angle 3 is equal to angle 4, angle 5 is equal to angle 6. So with one more piece of information, I can prove those triangles on the right are congruent. So I know that PN is equal to PN by reflexive. And then those triangles are congruent because of angle side angle for congruent triangles. So let's see, let's name those triangles. Triangle MPN is congruent to triangle OPN. And then because those triangles are congruent, we can now use all of their corresponding parts. So I'm thinking that if we can say that MP is equal to PO because corresponding parts of congruent triangles are congruent. And then I can mark that. And then angle 1 is equal to angle 2. And the reason angle 1 is equal to angle 2 is because they are supplements to equal angles. And supplements of equal angles are equal. Now, we can do that. Angle 1 equals angle 2. And then we can say that LP is equal to LP by reflexive. And then you can see that the triangles LPM and LPO are congruent. And the reason that they're congruent is because of side angle side. Now let's say at this point I did not see that angle 1 was equal to angle, or I didn't remember that theorem that said supplements of equal angles are equal. I could go with angle 1 plus angle 4 is equal to 180, and angle 2 plus angle 3 equals 180 because of angle addition postulate and the straight angle. And then because they're both equal to 180, I could say that angle 1 plus angle 4 is equal to angle 2 plus angle 3, and that would be substitution. Then we could use a subtraction property of equality to subtract angle 3 and angle 4 from both sides and end up with angle 1 is equal to angle 2. And so that would be, again, doable. So if you forget that theorem, it's not the end of the world. You can always go ahead and prove it anyway. And that's it.